Okay. Coming to you on a recording. 4.1. Slope, linear functions. Welcome to Calculus in the AM. This is Monday. In case you're joining us tomorrow, it will be Tuesday tomorrow. This is live but recorded. So, slope, linear functions. No real calculus yet. Here. Limits are calculus, but this here is another review that we need. Now I want you to take a look here. This should not be news here. If you have 2 points, point 2 and point 1. Why do I call this one point 1? Because I have y1 matched to it, x1 matched to it. Okay. I think we know the slope in words, rise over run, right? Keep that in mind always. And if it's falling instead of rising, it's negative, right? Slope. From left to right, positive slope. Change in y over the change in x, you guys have talked about that way in words, right? And sometimes you use delta y to mean change in y. And always final minus initial, y2 minus y1, x2 minus x1, stuff like that, right? There's something called the point slope formula. Pardon me. Do you guys remember what the point slope formula is? You will in a minute. Everybody agree that they remember this one? Think of this formula then and just rearrange it. Meaning, multiply up the denominator and it eliminates it on this side, right? And basically just zips it up here, m times x minus x. Agreed? So, it's a variation of this formula, except that instead of using y2, I'm going to just say y minus y1. Now, I'm moving my left and right reversed by here. Rearrange for this. Y minus y1 is equal to m x minus x1. That is the point slope formula. But do you see where it comes from? As long as you know the slope formula, you think, oh, I got a point. When would you use this? Well, it's called the point slope formula because if you want the equation of a line and you have the slope and 1 point, this is your best bet, okay? Of course, everybody's familiar with mx plus b, right? Good. Slope intercept. If you're given a graph, that's the easiest one. Now, remember, slope gives a rate of change. This graph here I've gotten from grade 10 science. There. And then it's a piecewise function, 2 pieces, right? Hitched together. Now, the slope gives a rate of change. I put this on here because it's an application question. If I have distance and I have time, let's just talk about the slope between 0 and 4, okay? On this graph here. So slope between, now I said 0 and 4, but they're time values. T equals 0, t equals 4 seconds, right? Okay, between 0 and 4 seconds. What is the slope there? I know it's negative, but what minus what? So between here and here, right? 40 minus 20, okay. Is there a unit on 40 and 20?
Meters.
Okay. Let's just put this over, because it'll help us describe this rate of change. 40 minus 20, if I do it in that order, I've got to go 0 minus 4. That's in seconds. Now, the arithmetic isn't too hard. 40 minus 20 is 20. Negative 4 on the bottom, right? You all dig that? Yeah.
Wouldn't it be 4?
I'm sorry?
Wouldn't it be 4?
Well, you guys gave me this order, 40 minus 20, correct? I'm thinking this is 2 minus 1. So if I do the y minus y in this order, I have to do this corresponding x value in that order, 0 minus 20. So you could have done 20 minus 44 minus 0. Same answer. Regardless, though, we got 20 divided by -4, right? -5 is the slope. Now, I put units on there because it makes some sense. And then meters over seconds, meters per second. -5 meters. I'm going to use a flat fraction. I tend to with units because you see them better. That's -5 meters traveled every second. All the -5 means is if I'm going to the right, I'm calling that a positive direction. -5 would mean I'm probably traveling to the left. So if I say east was positive, I'm traveling to the west, -5 meters per second, right? So slopes give a rate of change, and in physics and in science, speed, distance, and time, the speed is the rate of change that you're talking about here. That's why I use this example. By the way, between 4 and 7 seconds, what's literally happened according to this graph? Starts at 20 and it ends at 20. He's not moving, right? Standing still. Standing still. Okay. 0 speed, right? So horizontal lines, 0 speed. Is it possible, it's not on this graph, but is it possible to have a realistic situation where you are at, I guess, 48 and 25 at the same time? No. That would be an infinite speed. That would involve being at 4 seconds, being at this point, this point, this point, at all different times. It's like Star Trek, kind of like beam me up, but at the same time it isn't, because Star Trek beam me up would be here and here at the same time, right? Nothing in between. This is everything, all points in between. I don't know, unless you were that massive that you covered 25 meters or something. I don't know what that was. Anyways, it doesn't make sense, right? Infinite slope, infinite speeds are not possible with the physics as I understand it. There we go. So, we know this. We know this. Vertical lines have an equation. The one I was just showing you would have been x equals 4, or t equals 4 in this case, where a is a real number, right? So that's a straight up vertical line. The general equation of a line. Be aware of this. I don't find it all that useful, but sometimes you see it. The trick here is no fractions. A is not negative. The number in front of the x is negative. Sometimes some books you'll see a variation where they'll have the c on this side. Oh, I didn't mean that. But anyways, ax plus by. So 3x minus 2y equals 5. That's acceptable too. Depends on your teacher, book, and how crowded they are. Parallel lines have equal slopes. Meaning, if this is 2x plus 5, this is parallel, this is y equals 2x. Same slope, not news. Okay, from your textbook, page 9 and 10, there's a few things, and I have this, try this form. You could try this one first, I guess. And then I'm going to just double check with that assignment and see if those are all worthwhile doing or not. Because I'm not into wasting your time. You can always do more questions if you'd like, but I mean, I'll state the slope just by looking at that. Yeah, that's an easy one. Good too. Yeah, 3 is good. Yeah, 5 is good. Okay, double checking what I thought would be useful. Okay, not too shabby.